Alright, hello everyone. My name is Olivia, and today I will be presenting nitric oxide supplementation. So what is nitric oxide? According to nurse anesthetist Rachel Null, nitric oxide is a gas found in the body that causes blood vessels to dilate. This allows more blood flow into the heart and other organs. It also acts as a signaling molecule between nerve cells. In addition, it plays an important role in our immune system and helps to fight infections and stimulates the release of specific hormones such as insulin and human growth hormone. And then according to Linda Crampton, author of Nitric Oxide, Functions, Effects, and Dangers, nitric oxide is synthesized from the amino acid arginine, which is found in certain meats, fish, dairy, some nuts and seeds, and it's also converted from, so nitrate converts into nitrite in the body, and then nitrites are converted to nitric oxide in the body. So nitrates are found in foods such as beetroot and other green leafy vegetables. So today I'm going to present studies that address the following claim that dietary nitrate supplementation has been demonstrated as a promising approach to improve exercise tolerance and time to exhaustion because it boosts our nitric oxide production. So the first study I'm going to discuss is a 2019 peer-reviewed study that presents the effects of nitrate supplementation on time to exhaustion, muscle fatigue, and perception of effort and leg muscle pain. It's a randomized double-blind crossover design with 12 recreationally active males who completed a dynamic time to exhaustion test of the NEEG sensors after 5 days of consuming both nitrate-rich and nitrate-depleted beetroot juice, which the depleted one is the placebo. The time match conditions. So the variables I'm going to be discussing today is the perception of effort and leg muscle pain, the time to exhaustion, and the muscle fatigue, the effects on muscle fatigue. So here is the results of the study. So it found that people who took nitrate were able to exercise for a longer period of time, with a mean of 12 minutes and 41 seconds compared to the control group, which was a mean of 9 minutes and 3 seconds, with a p-value of 0.01, which indicates that this difference is statistically significant. And then as for this graph, on the left is when the males took the placebo, their time to exhaustion, versus when they took the nitrate supplements, their time to exhaustion. So 8 out of 12 of the participants improved their performance over a range of 9 to 51%. As you can see here, there's a few that do go down, but the rest pretty much significantly improved their time to exhaustion with nitrate supplementation. So the study also found that compared to the placebo, participants reported significantly lower levels of perceived effort both during and after exercise while taking nitrate supplementation with the p-value of 0.027. Additionally, participants also reported lower levels of leg muscle pain while taking nitrate compared to the placebo. So in conclusion, the study found that exercise tolerance during high intensity was improved after 5 days of nitrate supplementation, as indicated by a significantly increased time to exhaustion. 8 out of 12 participants improved their exercise tolerance after 5 days of dietary nitrate supplementation. Those who did not improve their exercise tolerance might have benefited from a higher daily dosage or longer supplement period. It also showed that 5 days of nitrate supplementation was associated with reduced levels of muscle fatigue compared to the time-matched placebo condition, and dietary nitrate supplementation was accompanied by a lower effort perception during exercise. The second study is a 15-day original research study completed in 2019. And we get to see the results of 15 days of nitrate supplementation on cycling performance. So the results of this study were after 15 days of the nitrate supplementation, there is a significant decrease in race time completion, an increased average power, and an increased speed average. While a single pre-exercise nitrate dosing produced no significant changes to these measures. So the study was a randomized, double-blind, placebo-controlled experiment. It included 2 groups, a multi-dosing group of 14 subjects, which included 8 men and 6 women who took a nitrate supplement for 15 days leading up to the trial. The second group is a single-dosing group, which consisted of 15 subjects, 7 men and 8 women who took a placebo for 14 days leading up to the trial and then took a single nitrate supplement the day of the trial. So the subjects were, they met the following inclusion criteria: being between the age of 18 and 29, were recreationally active, and they were asked to maintain normal physical activity and exercise levels during the participation. And then here is the descriptive measures between the multi-dosing versus single-dosing group. Everything was held very consistent between the 2 groups. And so the time to completion, so this is the 2 groups' time to completion before the supplementation, and then here is after. As you can see, the black is the multi-dosing group, and their time to completion for cycling was significantly lower after the 15 days, whereas the placebo or the single dosing group who took the only one single supplementation the day of the trial, they barely decrease their time to completion, and the p-value is 0.01, so it's very significant, statistically significant. In this graph, we can see the pre versus post treatment change in time trial performance variables. So with the multi-dosing, their time to completion on average went from 17.9 to 16.9. Their average power went up. Their peak power actually decreased, but their average speed increased, peak speed slightly decreased, where the single dose had little to no changes. So the results were that 15 days of nitrate supplementation at a daily intake of 500 milligrams improved cycling time trial performance, as well as power average, output, and speed average, while a single pre-exercise dose failed to elicit any ergogenic effects. 10 out of 14 subjects exhibited improved average power and faster race times following a 14-day nitrate supplementation, while a majority of placebo-treated subjects showed no change. In aggregate, subjects demonstrated a significant 5.6% decrease in time to completion with 15 days of the nitrate supplementation. And then the third study is a 2016 meta-analysis entitled "The Effect of Nitrate Supplementation on Exercise Tolerance and Performance." So 3 research analysts used 29 studies to investigate the effect of nitrate supplementation on exercise tolerance or performance, using only studies that were an experimental trial published in an English peer-reviewed journal. They had to compare the effects of inorganic nitrate consumption with a non-bioactive supplement control or a placebo, and used a quantifiable measure of exercise performance, and was carried out in apparently healthy participants without disease. And like I said, there are 29 studies included. So the results were that time to exhaustion as the outcome variable revealed a significant effect of nitrate supplementation on exercise tolerance compared to the placebo, and using time to complete a specific distance as the outcome variable revealed no significant effect of nitrate supplementation compared with the placebo. So nitrate supplementation, according to this meta-analysis, is likely to improve exercise tolerance and capacity that may improve exercise performance. So would I recommend nitric oxide supplementation? I would recommend it to patients who have a low exercise tolerance, as well as patients with type 2 diabetes or arterial disease in which muscle fatigue is exacerbated, or to individuals who want to exercise for longer periods of time, and individuals who may be seeking to decrease their blood pressure through nutrition and fitness, or endurance athletes who want to decrease their cycling, running, swimming time, etc. But for the most part, I feel that most, if not all, athletes could benefit from nitric oxide supplementation. And according to one of the studies, athletes can benefit from taking beetroot supplements 500 milligrams daily, but some individuals did not respond to this amount, so depending on the individual, we may need to increase to a higher dosage. And for individuals that are opposed to taking supplements but would still like to benefit from nitric oxide increase, since nitrate is found in leafy greens and beetroot, I would recommend to increase the intake of these foods, as well as foods that are high in arginine, since arginine gets converted into nitric oxide in the body, which includes some meats and fish and nuts and seeds. So yeah, and then here are my references. Thanks for watching.